again. Feel free to write down notes. Let's just start with number 6. Because you certainly, for number 6, would want to write the formula for the area of a parallelogram. And remember, area of a parallelogram is just base times height. Okay, and they just wanted parallelogram A, B, C, D. Really, it's no more than a little square that's squashed. And you just have to remember that anytime you see the words base and height in math, they have to be perpendicular. So you got to look for that little square. And the little square is right here. 12 is the height, and the base is 12. It doesn't matter which of these you call base. So that's where they came up with the 144, and make sure you label it as inches squared. Okay, and then that leads us to number 7. I'll get to number 7. The area of a trapezoid is 1/2 of base 1 plus base 2 all times the height. And if you remember talking about this, the two bases are the two parallel lines. These are the parallel lines. So you've got this long line, because we're talking about the trapezoid now. The long line is 12 plus 10, so that's 22. The short line on top is 12. Height is still the same, so it's still the square corner you're looking for. The height is 12. And then you just do the math from there. What is this? 34 cut in half is, well, 34 cut 12 in half, you get 6. So multiply 34 times 6. Is that right? Did I do something wrong? That can't be right. What did I do wrong?
It's 204 inches squared.
I know, because this is 34.
We have to do half of 34. We're going to do.
Why did half with 12 though? Oh, 6 times 3 is 18 plus 2, 204, sorry. 204, and again, square inches, so I would definitely have these formulas put on a piece of paper with some notes to yourself. You should not miss those. Those should be incredibly easy. Oh, and then there's triangle ADE. You're going to use the same height thing. Area is 1/2 base times height. And again, the height was 12 because it's the thing there that gives you that, and the base is 12. Half of 12, what is that, 72 inches squared.
So they had 6.
What?
The base
Oh, wait.
times 12.
Oh, I gotta look at the right triangle. I was just, sorry, getting a little carried away. It's 10 for the base, 12 for the height, so 12 times 10 cut in half. My bad. Got a little crazy there. 60 inches squared. Perfect. Good for you and good for me. Nick Shanks, number 3. How do we do number 3? 5 minutes is what percent of an hour? So really, you could do the fraction box thing or percent box, okay, but you're not really splitting an hour into, well, yeah, I guess you are splitting an hour into two. You are just taking 5 minutes. 5 minutes is what fraction of an hour, Nick? How many minutes are in an hour? So you're looking at 560 is the fraction that you just need to change into a percent. 560 is what number over 100? And there again, this is one of those ones that doesn't work out evenly. You could reduce 5/60ths to 1/12, but you're still going to end up having to do some math because 12n equals 100. Take 12 divided into 100, you're going to end up with that 8 1/3, right? That is a percent because that's how many out of 100. You could have divided 60 into 5 and get the decimal and change that to a percent, or you could just say this is what number over 100. Same thing as the percent there. Will tomorrow's be a lot like that? I don't know. Oh, sure it will. Something like that. Not Kikala.
I don't get how to do number 8.
8?
8.
Didn't I already do 8? They go over too fast. The triangle?
Yeah.
Where'd my triangle go? Alright, well, let's look at this again. Okay. Might as well click on that. Why does it keep doing that? Alright, I'm going to erase this. We're looking at the triangle, right, Nikki? Formula for a triangle is
1/2 base times height.
1/2 base times height. And this is the triangle, so this is all we're worried about.
I have the wrong shape.
Okay? Well, they said triangle ADE or whatever it was.
Yeah, I did the one that like.
So this is the base, that's the height. Multiplied together, cut it in half.
Sorry.
Wait,
I'm understanding the answers to problems. 11.
number 11, is that the other page? Use, oh, and here's one, people write this down as a note to yourself. If you got, somebody got 18, when somebody said the answer to that, and I see why you got that, but again, when you use square units, you have to think in terms of doubling, because square units is 2 labels. 54 square feet. It's not the 54 that gets squared, it's the feet that get squared. You have 54 feet times feet, that's where your square units come from. If you put that over 1 and use unit multipliers to cross cancel, you need 2 identical ones because you have 2 labels that need to be crossed off. Okay, you need a foot there and a foot there. You're changing them into yards. There are 3 feet in 1 yard. And that's where if you cross things out, you end up with yards squared, which is what you want, square yards. It's going to be 54 divided by 6. 54 over 6, and that's where the 9 comes from. 9 yards squared. So there's a grade 1,
Wait.
I mean 9 and 6, sorry. Sorry all of you in TV land. 9 into 54 is 6. So there's a great one to leave a note for yourself that you have to double the unit multipliers because it's square feet, square yards. That's only the 3rd mistake I've made today. John Nyer.
I still don't understand 19.
You say that like I explained it once to you and you didn't get it?
Yeah. Yes, right.
Really? Oh. 19 is a great review problem. Okay, try to focus with me here. To simplify square roots, we had a couple steps we did. The first thing we were supposed to do is prime factorize them. And then I will do this the hard way, and then for those of you that are mathematically inclined, you can use a few shortcuts here. But if I'm breaking down the square root of 3,600, what does that break into? Well, the square root of 36 times the square root of 100. What do those break into? Well, the square root of 6 times the square root of 6, square root of 10 times the square root of 10. What does that break into? Square root of 2 times the square root of 3, square root of 2 times the square root of 3, that gives me my 2 6's. 10 is the square root of 2 times the square root of 5, square root of 2 times the square root of 5. I would then probably put them in order from the smallest. I got 1, 2, 3, 4 square roots of 2. I've got 1, 2, 2 square roots of 3. And I've got 2 square roots of 5, all times themselves to give me this 3,600. And the second rule is, if you have identical square roots, okay, 2 same square roots cross off to give you a normal number. In other words, this. 2 square roots of 2 cross off and give you just a normal 2. Another 2 square roots of 2 cross off to give you a normal 2. 2 square roots of 3 cross off to give you a normal 3. 2 square roots of 5 cross off to give you a normal 5. You just remultiply those, which is what, 60, and you'll end up with what times what gives you 3,600. Now, for those of you, and probably most of you can catch on to this part right here, I did a whole lot more work than I needed to do. Because as you're doing this, if you find perfect squares as you're breaking it down, for example, 36, square root of 36, you should know what times what gives you 36. So you could just stop here and go, oh, that's a 6. The square root of 100 is 10. Those both have crossed off, and then 6 times 10 is still 60. Okay, so problem number 20 along those same lines, what times what gives you 18? Square root of 9 times the square root of 2. Well, the square root of 9 is a perfect square, so you can just make that 3. Square root of 2 is not going to cancel out, so it stays the square root of 2. Or you could have broke 9 into the square root of 3 times the square root of 3, which still gives you this 3. You should be able to figure that one out. I love math. I'll be thinking of you at Camp Duncan. At this time tomorrow, what do we do at 9:15?
Driving, probably.
Oh, yeah, it's
No, we'll just take us down one. There, we leave at like 7.
Yeah, it's 2.5 hours. We won't get to about 10 or something.
We don't.
I'll drive.
I forgot.
We
It's
left
like,
at like 6:30.
We'll get to take the bus. Jack,
What was number 5 and number 15?
the answer to number 5 was 3/5, and the answer to 13 was 99. Corinne, I shall hammer your question out. What?
Okay, how do you do number 17?
17? Another good question. This is why this review has been so helpful to me. I hope your math test scores all stay the same at least this time, instead of going down as 8th graders.
What did we do?
Alright, anybody suggestions on what to do? This, by the way, is division. So what's the rules here, Emma Kreis?
You divide 1.2 by 2.
Yep, divide the left stuff out. So I'm going to take 1.2, divide it by 2, and I get 0.6. The second step is, you really divide the right. But what you do when you divide by the right is you subtract the bottom exponent from the top. In other words, and here's where you gotta be careful, because my bottom exponent is a negative 2. What happens when I take 5 and subtract a negative 2? What happens when you subtract a negative? It actually ends up being an addition problem. So this is times 10 to the 7th power, because you're subtracting a negative. Now, unfortunately, that's not my answer because it's not in scientific notation. I have to simplify that, move that decimal over. I made this one bigger, so I have to make this one smaller. So it's 6 times 10 to the 6th power. Oh, with this. Other questions? I know there's more. There's got to be more. Jackson.
We think she used our number.
Number 1. Ladies and gentlemen, number 1 as best I know.
It's pretty darn easy.
Who said that? Oh, Jack. 3 out of 4 doctors surveyed recommended the product. 60 doctors surveyed did not recommend the product. How many doctors were surveyed? A ratio box is going to do you wonders here, Jackson. And what are we comparing? We're talking about the doctors surveyed the doctors that were not surveyed, and then we've got total. 3 out of 4 doctors surveyed. So how many doctors were surveyed? How many total doctors were there? No, there was only 4. 3 out of 4 surveyed. It didn't say 3 were surveyed and
No,
4
no,
were
no.
not surveyed.
4 were surveyed. Actually,
Three
there
or four
were,
doctors.
3 out of 4 doctors surveyed. 3 out of a total of 4 doctors surveyed recommended. So these are the ones that recommended, sorry. Not recommended. So 1 out of 4 would not recommend whatever it is. 60 doctors surveyed did not. 60 did not recommend the product. How many doctors were surveyed? 1 out of 4 equals 60 over what number? What's that? 1 times 60, 4 times 60 is 240. It wasn't not surveyed, and surveyed, it was doctors recommend, not recommend, sorry. Is that like my 4th mistake today? It's hard to get back into the swing of things. Is anybody going with number 2 while I'm right there? Sage 2? Perfect. I like 2. 2 is not a bad one. A used car salesman purchased the car for $4,000 and sold it for 40% more. What was the selling price of the car? Well, Sage, the first thing we have to understand is what type of problem is this? If the guy sold it for 40% more, how am I going to set that up? No, I'm going to do my percent things here. I have my original price, right? And what am I doing to that original price? I am adding to it, correct? He sold it for 40% more. So this is an increase. And then is your final price. What was my original percent, Sage? Original percent is always 100. How much did he increase it? 40%. So the final price was what percent?
240.
Put those two together, it's 140%. He purchased the car for $4,000, that was the 100%. What was the selling price of the car? So there's your nice little fraction, it's gonna work out pretty nice, I think. 100 over 140 equals 4,000 over what number? Sage, what do I gotta do here? To go from 100 to 4,000, I would multiply by 40. So I just need to take 140, multiply it by 40, and I should get the selling price of the car. 0, 0, 16. How about $5,600? What? Is that wrong?
I just wanted you to do it, because I could write notes down.
What's that?
So I just wanted you to do it. So
Like you couldn't write notes on anyway?
well, I don't really write it, but I
There are other ways to do it. My way is not the best way, it's really the only way. Let's see what our thing looks like here, shall we?
Are we gonna have to do problems?
Jackson? No, you'll skip the same problems.
I have a question.
15? Number 15, what's your question, sir?
I got x equals 3 and then x equals 4.
Well, let's break it apart here. First thing you should do in 15 is
Oh, right there.
4x minus 1x.
3x.
Right, you can combine those two. So you get 3x's minus 5 equals 7. Now what?
Make it like
Get x by itself by adding 5 over. Now 3x equals 12. Just divide by 3. Divide by 3. X equals 4. Nikki Kyle.
I'm confused with number 18.
Not as much as I am.
X, Y cubed at the bottom.
I was thinking somebody would ask about 18. What is this here? Sorry, I'll erase a little bit. All right. Who got this right? John Nair, can you tell me how you did do this? Just because there's a bunch of different ways I could tell you to do, but I don't remember what we said to do in the end here.
Base divided 24 and 16 by 8.
Okay, well, let's start with that. Working with the numbers, that's the easy part. 8 goes into both of them, so you end up with a 3 on top and a 2 on the bottom. I'm wondering about what you did, how you did the letter part, John.
And then the negative, I moved down. to
Okay, so
cube.
John says, I don't like to work with negative exponents, so I'm gonna move this y to the bottom, make it y to the positive 1 power, because that's how you change exponents from negative to positive from top to bottom. Now, John?
I cross canceled x.
Okay. X squared means you have 2 x's times themselves on bottom. X cubed means you have 3 on top. So 2 of those will cross off with 2 on the top and leave you with a 1x left on top that didn't cross off. And then on the bottom you can just combine the 2 y terms. Y to the first and y to the second is y to the third. So you end up with 3x on top and 2y to the third on the bottom. That's probably the best way. Make your negative exponents positive by flip-flopping them, and then just combine and cross cancel. Nick? Yeah, you can, the difference is, you can do that a whole bunch of different ways. Just like first 12. And even though John says that looks like a square base, you could do it, Nick, did you do it like this? Here's your base. I don't know. Looks like you do a square like this. I don't know why that did that. Triangles like this.
I did that.
You could do it like this. How come nobody did it like this? Do your little square thing here. Do your other little, oh wait, do your triangle here and then do a square thing off of there.
Yeah.
Triangle here, do a square thing off of that.
That's what Nick was like.
Or make a
Well, could you put 2 square things on one of the triangles?
Since we're right here too, please understand for this, what is it, this? When you see a formula for sequences, the letter N is always the number of the term. So if they tell you they want the 50th term, you put that number in for the letter N there. And as we said, look at, what's that called? The N and the A, that's called a subscript. Subscripts, when you put things in there, are not numbers that you're using for calculation. They're numbers you're using for labeling. In other words, when you read this, you say the nth term of A, you say the 50th term of A is this. You don't use this. This A does not get figured in your calculating. You're not saying, 50A. It's just a labeling purpose. That's what that 50 is right there. Here, it's not a subscript. It's a variable right next to a letter, so it's multiplication. So really, you say it like this. You do A, the 50th term of that sequence is 2 times 50 minus 1, which gives you that 99. Subscripts, superscripts we call exponents. Subscripts are just there for labeling purposes, so you can keep things straight. So this does not turn into any sort of a number ever. It's just a way to label the problem. 50th term is. Oh.
I know I didn't do 14, but what is this?
That's how they show the Pythagorean theorem.
Oh, yeah.
That is the Pythagorean theorem. In other words, what they'll do is if this was a 3, 4, 5 triangle, and you drew squares off of those sides, you're going to get an area of 9 here, an area of 16 here, and it just shows that area over there is going to be 25. just gonna show you that. We didn't talk about it, don't worry about it, don't put it on your paper, don't do anything with it. We will be skipping it. Austin, number 5. Did we do number 5 already?
That's what I was gonna ask.
That's what I was gonna do. Number 5, people, don't overthink it. Okay? Probability is just how many out of the total. This right here is your probability. It's just 24 out of 40. That is your probability right there. Okay, the probability you're going to make the next basket is 24 out of 40, which reduces down to whatever it is. What, 4 goes into there, 8 over 10, 4 over 5.
I got 6 over 10.
8, what did I do? Divide by 3. Oh. Here, let me try that again. Mistake number 7. 24 over 40, 8 goes into both of them. 3 over 5, sorry. Good thing I'm not taking this test. It could be a long one for me. But you don't, there's no magical formula on this. You just know that probability is how many over total. And this one you can't draw the, there's no ratio box or fraction box or whatever box. Please tell me there's more. Please, please more. Oh. Wait, number 10 we did immediately? No, number 10 we didn't have to do. I don't have that kind of time. Number 9 we didn't have to do? Oh. I can tell you what number 9 is. How do you know if something's direct variation? Exactly. It has to go through the origin and it has to be a straight line. That's all it has to be. It's also called proportional or whatever. Is that everything then? Anybody? We really did it all.
We didn't do one.
We didn't do 16.
Which is, but that would be good.